Imagine looking up at the night sky, right? At a star that looks, well, pretty ordinary, only to discover it's secretly blown this colossal bubble, a structure so huge it holds the mass of our entire sun, and yet the star itself, it hasn't gone supernova. That's exactly what astronomers found around a star called DFK 52. And yeah, it's really baffling. Today we're taking a deep dive into this cosmic enigma. We'll be looking at an article from SciTech Daily. Scientists think this star could be the next supernova, and also some research bits from DFK 52, the next supernova. It's a story, it's packed with cosmic drama, incredible scale, and some really big unanswered questions. Questions forcing us to rethink how massive stars actually, well, die.
Yeah, what's really fascinating here is how it just challenges some core assumptions we have, about how these massive stars end things. Red supergiants, like this DFK 52, we already know they have spectacular finales. But this one? It throws a real twist into the mix. It's like adding a whole new unexpected chapter to the story of stellar evolution.
Absolutely. So for this deep dive, our mission is basically to help you get your head around the details of this cosmic mystery fast. We'll unpack the discovery, really marvel at the sheer scale of this bubble. It's almost unbelievable. Then we'll get into that perplexing question, why didn't it fully explode? And finally, think about what this might mean for our galaxy. Could DFK 52 really be the Milky Way's next big stellar explosion? Okay, let's get into it. So our star of the moment, DFK 52. It's a red supergiant. Now, when you think red supergiants, probably the first one that pops into your head is Betelgeuse and Orion, right?
Right, famous one.
Well, DFK 52 is basically a cosmic cousin to Betelgeuse. Another one of these truly enormous older stars, glowing red, nearing the end of its life cycle. We've actually been watching Betelgeuse closely too, with its weird dimming events. Sparks similar questions about what happens right before they pop. And this incredible finding about DFK 52, it comes from astronomers over at Chalmers University of Technology in Sweden, led by Mark Siebert. They weren't just pointing any old telescope at it. They were using ALMA.
ALMA, the Atacama Large Millimeter Submillimeter Array.
Exactly. Down in Chile. It's a world-class setup that lets us see things totally invisible to our eyes. Specifically, they were tuned into light around 1.3 millimeters wavelength.
And that wavelength is key, isn't it?
Totally. Because that long wavelength light, it lets ALMA just slice right through all the cosmic dust and gas that usually hides stuff like this. It lets them see the cold gas molecules like carbon monoxide, silicon monoxide, the actual boarding blocks of this huge bubble, stuff you'd completely miss in visible light.
And zooming out a bit, these red supergiants like DFK 52, they are just crucial for understanding how stars live and die. And not just the stars themselves, but the whole galaxy's evolution. We're talking stars that started out more than 8 times the mass of our sun. Massive. In their final phases, they don't just fade away, they create and then violently eject heavy elements.
Like oxygen, carbon, iron.
Exactly. Stuff created inside the star, they throw it back out into interstellar space, and that material seeds the gas clouds for the next generation of stars and planets.
So they're basically galaxy shapers.
Absolutely. Essential for cosmic alchemy, really, making the stuff needed for new stars, planets,
Right.
maybe even life.
But even knowing all that, sometimes the universe just throws you a complete curveball.
It certainly does.
And that's what happened here. Mark Siebert, the lead astronomer, he said, "We got a big surprise when we saw what LMA was showing us." He said, "The star is more or less a twin of Betelgeuse, but it's surrounded by a vast, messy bubble of material." And that messy bubble, well, that's where things get really wild. Okay, so this bubble, it's not just any bubble. This is, hands down, the largest structure of its kind ever seen around a red supergiant. In the entire Milky Way,
It's staggering.
it contains as much mass as our sun, our entire sun, but spread out over 1.4 light years.
Light years.
Yeah. To put that in perspective for you,
Right.
that's thousands of times wider than our whole solar system out to Neptune.
Just mind-boggling scale. Our solar system is a tiny dot compared to that.
Right. And here's another way to picture it. Imagine DFK 52 was as close as Betelgeuse is, this bubble. It would appear to cover about a third of the full moon's width in our sky.
Wow. Not just a point of light, but a visible cloud.
Exactly. A huge visible structure created by one star. Just imagine seeing that. It gives you a real sense of the power involved.
Which brings up the big question, how does something like this even form? So the team, including Alvear de Beck, they use the Doppler effect to figure this out.
Like the ambulance siren thing?
Precisely. Same principle, but with light waves instead of sound waves. The light from the gas gets shifted, blue shifted if it's coming towards us, red shifted if it's moving away.
Okay.
By measuring those shifts across the bubble, they could literally see it expanding outwards. in all directions. And they could calculate when it started, about 4,000 years ago.
4,000 years.
Which, in cosmic terms, as Elvira de Beck said just a moment ago, blink of an eye.
So the bubble's still moving outwards.
Yeah.
Fast.
Oh, yeah. Tremendous velocity. It's like this cosmic smoke ring still spreading out from this incredibly powerful, ancient eruption. It wasn't a gentle puff. This was a violent, explosive ejection of material.
That's incredible, the force needed. Well, and like you said with the Doppler effect, it's not empty space expanding. It's actual stellar material, those stars' own guts being thrown outwards.
That's right.
The researchers said the bubble is made of material that used to be part of the star. It must have been ejected in a dramatic event, an explosion.
Oh.
And here's where it gets really weird, where astronomers are scratching their heads. How does a star throw off the mass of our sun violently, but still be there?
Yeah.
What stopped it from just completely blowing itself apart?
That is the million-dollar question, isn't it?
It really is.
Yeah.
Why did DFK-52 shed so much mass in what looks like a near supernova event without actually being a supernova? Red supergiants, I mean, they're supposed to end in a supernova. A spectacular collapse.
That's the standard picture.
But the star ejected a sun's worth of mass, and it's just still sitting there. It's like seeing a building gutted by a huge explosion, but somehow the main frame is still standing. It's odd.
That's a good analogy, because usually we see these big mass ejections as like the precursor, the final gasp before the whole star collapses into a supernova. But the scale of this one, ejecting a whole sun's mass without the complete collapse, that's what's really puzzling people.
So it suggests something more complicated is going on.
Exactly. It suggests maybe a more complex process, maybe even a different kind of process happening in this critical pre-supernova stage, something our current models just don't fully capture. It's like finding this totally unexpected chapter in the textbook on how massive stars die. Forces us to rethink what we thought we knew.
So, okay, what could possibly explain something this weird? What are the main ideas floating around?
Well, a leading theory, one Mark Siebert suggested, is maybe DFK-52 isn't alone. Maybe it has a hidden companion star.
Ah, a binary system.
Right. And this isn't just a wild guess. We see binary interactions dramatically changing how stars evolve all over the place. Picture two massive stars orbiting close. Their gravity could literally tug or strip the outer layers off one star.
Like a cosmic tag team?
Sort of. It could trigger this kind of massive outburst without causing the core collapse needed for a full supernova. It's a known, powerful mechanism.
That idea of a hidden companion?
Yeah.
It's compelling.
Yeah.
But I wonder, do we sometimes lean on binary systems a bit too much to explain weird stellar behavior?
That's fair.
Could there be something inside the star itself, some instability we don't understand yet?
That's a really good point, and it's definitely part of the debate. The binary idea is strong because we have evidence for it elsewhere, but confirming it here is tough. Companion stars can be really hard to spot, especially if they're faint or hidden in a dusty orbit.
Right.
So yes, people are also considering other things, maybe extreme internal instabilities, like some kind of super powerful pulse pushing out tons of material without a full collapse. Some even mention maybe a late interaction with a giant planet, though maybe less likely for this much mass. The truth is, this discovery really pushes us to question assumptions. We often picture stars alone, but binary and multiple systems are super common, and that gravitational dance, it can totally change the script for how a star lives and dies, maybe triggering exactly this kind of massive but not quite fatal eruption. It just reminds us the universe is rarely simple.
Okay, so DFK-52, red supergiant, end of its life, just had this massive outburst, like a cosmic burp the size of the sun. What happens next? Could this actually be it? The Milky Way's next supernova, maybe one we could even see. That's pretty exciting.
Yeah.
Like watching a countdown.
Well, looking at the big picture, red supergiants are expected to explode eventually. That's their destiny. And while they can shed mass periodically, the sheer scale of this DFK-52 bubble is just off the charts, which makes its future really interesting. Elvira de Beck noted, if it's a typical red supergiant, it could go any time in the next million years or so.
A million years, okay, cosmic timescale.
Right. But understanding this weird event, this huge pre-explosion shedding, that might actually help refine the timeline. It gives us clues about what to look for in other massive stars that might also be getting close to the edge.
So we're not just sitting back and waiting then. Astronomers are actively trying to figure this out.
Oh, absolutely.
Like, what specific observations could tell us if it's really the next big show?
Yeah, that's the exciting part. They're not just leaving it there. More observations are already being planned. They want to use even more sensitive instruments to hunt for that possible hidden companion star. Finding one would be huge support for that theory.
Makes sense.
They'll also keep monitoring the bubble itself, how it's expanding, look for tiny changes in the star's light, maybe even signs of another event build up. It really is like a cosmic ticking clock.
Yeah.
Yeah, not on our time scale. It's slow motion drama playing out over millennia.
And this isn't really just about DFK 52, is it? This feels like it has much bigger implications.
Absolutely. Way beyond just one star. Every time we stumble onto an anomaly like DFK 52, it forces us to go back and check our models of stellar evolution. That's how science moves forward, right? By being surprised.
Yeah.
It makes us rethink everything: how stars are born, how they interact, how they die, and crucially, how they spread those heavy elements needed for planets, for life. I mean, if this kind of giant pre-supernova shedding is more common than we thought, that could change our estimates for how often supernova happen, how quickly elements get recycled, basically how galaxies themselves evolve over time.
So we've taken quite the deep dive today into DFK 52, this red supergiant that's, well, both a cosmic marvel and a really deep mystery. We've seen how its absolutely enormous sun mass bubble really challenges how we think stars die, and how it might even point to a hidden partner star messing with its final act. And we've definitely wondered if this strange star is truly lined up to be our galaxy's next spectacular supernova, giving us maybe a front row seat to one of the universe's biggest shows.
It really does highlight just how much more there is to learn out there, doesn't it? Even about things we think we understand, like stars dying. We keep finding new layers, new processes, things we hadn't imagined. So maybe something for you to think about is this. If one star can shed the mass of our sun without completely blowing up and hold on to that secret for 4,000 years, what other incredible, maybe even paradigm-shifting events are happening right now, just beyond what we can currently see, waiting for us to find them? It just reminds you the universe is probably far stranger and more wonderful than we can even guess.
Great thought to end on. Thanks for joining us for this deep dive. Until next time, keep looking up.